We did. That's a true statement. So let me refine my question a little bit. Mathematically, what did we talk about? Does anyone? What's the idea of or? Is there a really quick summary? I'm sorry. Go ahead.
What we talked about is like if there was 3 doors and you chose door 1, and they told you that they eliminated door 3, but they didn't eliminate door 2, and they asked you if you wanted to switch your door.
Yeah, exactly. So there's a life lesson, kids. Anytime you suddenly find yourself in that situation, you know what to do now. You're welcome, because it happens all the time. Okay, so can somebody tell me an operation that goes along with or? What operation does or imply? Add. There's an operation, right? So or means add. You with me? And this is actually really, really big. Because later this semester we're going to see situations and I'm going to say that's an or, that's addition. And I just want you guys to be like, of course it is. Keep going. So or basically means add. So it makes sense. The formula is if I have the probability of event A or event B, it should involve addition. Makes sense. So why isn't it just straight up PA plus PB? Why isn't that where we stop? Why do we have to do one more thing?
You need to do adjustments.
Say again?
You need to do adjustments.
Adjustments. Why would I have to do an adjustment? Sorry. Repeats. So if I do all the stuff in A plus all the stuff in B, I might have counted somebody twice. So if I'm asking, what's the probability somebody owns a motorcycle or goes to watches movies? Do you think there's anybody who owns a motorcycle and watches movies? Oh, hell yeah. So if I add those two groups, there are some people who are in each group. They counted twice. They got counted twice. So I got to subtract them off. Yes?
Are we allowed to put these on our formula sheet?
Oh, hell yeah.
Are we going to remake one as a class? Or
We will. Well, you can basically make one right now if you want to. I mean, the formula sheet for the quiz, if I were you, I would just bring my probability formulas. I wouldn't bring all the other stuff and confuse the hell out of myself. This is only going to be about probability, this quiz. So if you want to sort of make your formula sheet, this is basically going to be it. Right? Okay. Some of you look dejected. I'm sorry. Hope everything's going okay. All right. So what about, give me another formula we talked about that we figured out. And. And's a little bit weird. We actually have to figure out and after we figured out given, right? So let's see. What was the formula for and? There's actually 2 ways to do this. Multiply. So you're going to multiply 2 things. Okay, sure. You can do PB times. Now, real quick, let me do it like this. Sorry. Remember how I wrote that first? Or is basically add, but there's an adjustment. And is basically multiply, but there's an adjustment. And you saw why. When I was picking stuff out, if I didn't put it back, the second dude changed. Of course it changed, because if I take a candy bar and eat it, now the probably I get another candy bar of the same kind is less. Does that make sense? So of course the next thing depends on what happened before it. Become a B. So Panba is Puba Pab. Sorry. All right. So then, what was the other way to write this? It's basically the same thing, just kind of reversed. If I do PA, I got to multiply that by PB, adjusted. Do you see how both of those say PA times PB? Just one of the two has to be adjusted because it could have changed based on what happened first. So this was like if B happened first, A's probability might change. If A happened first, B's probability might change. You with me? Okay. And then what's this guy?
given.
That's the given. I love it. So that symbol means given. That symbol does not mean divided by. Dear God. Write that somewhere for yourselves. Write that really big. Put a little asterisk next to it.
Can you repeat that? Sorry.
Given does not mean divide. It's really unfortunate we chose that symbol because I get people that just do PA divided by PB. No, it's a very different idea, right? What is the formula for this? Good. It's the and divided by the given. The and of them divided by the one that was given. And the nice thing, I'm telling you as if you have to memorize these, and you don't. They're on the formula sheet, but I want them to make some kind of sense as to what they're saying. This one we actually showed visually. If B happens, what's the only way A could also happen is if A is in B. The stuff that's not in B can't happen then, right? If I said, oh yeah, I picked a card as a diamond, what's the only way that an ace can happen is if it's the ace of diamonds. So it's got to be both then. That's why it kind of makes sense. The top is an and. Okay, maybe. I don't know. By the way, are you always going to use these formulas for any probability question I ask you? Hell no. If I give you a way to count everything, for example, that chart we did, you don't need formulas. In fact, they're going to make it seem worse than they are. Why do formulas do that? Because they have to capture every possible situation you could be in. So I think one of the very first things I want to do real quick before I unleash you on this worksheet, I want to do an example where you can't just count. You actually have to use the formula, right? So real quick. All right. Let's say this is an example. Do you see I'm on another board? Doing the same thing, right? That's formula sheet. That's really all you need for the quiz. Not formula sheet. Okay. Let's say that I know the probability of A is 0.2561, and I also know the probability of B given A is I'm going to get myself in trouble here because, let's see, if I don't make the numbers right, it's going to come out weird. And I want to know, let's see what else I can tell you. The probability of B is 0.5813, and I want to know what the probability of A or B is. Okay. This should feel more like an algebra problem. I don't know if you guys are with me on that. I'm giving you values that show up in equations, and you just have to put them in the right place. So here's the way to look at this kind of problem. This is my least favorite kind of probability problem, and not to say that I don't like algebra, but it's just algebra. There's no concept to it. Look at the thing I ask you for and find an equation that either is this or involves this. So what is the equation for this? Here's something. Do it again. Sorry. Yeah, it's over there. I love it. Probability of A plus probability of B minus probability of A and B. So this is a very just nuts and bolts approach to a question. Here's the question they asked me. Let me write the formula that answers that question, and let me step back and say, do I have everything I need? Do I have everything I need to figure that out? Do I have PA? Totally. Do I have PB? Totally. Do I have PA and B? Where? Where do you have that? I don't see it. You guys, is everybody with me? I really want you. What's up? Sorry. Who's not with me? Sorry.
No, I'm not getting. We have both PA and
Yeah.
PB, but we don't have.
We have these two things. We don't have this. So there's no way in freaking hell I'm going to answer this question right now, right? So what do I want to look for now? Obviously, what do I need to figure this guy out, right? So what's a formula for him? There's two of them, right? Is everybody with me so far? Because trust me, you're going to have not exactly this question, but you're going to get this question on the quiz. Yeah.
I feel like this is stupid, but why wouldn't you just add A and B to get the probability of A and B?
The only time that the or is just these two added is if you know that this is what? What's the only way that this can equal that plus that? Is if this is 0. Do you know that this is 0 for that problem? No, I have no idea what that is, right? Does everybody, you guys understand? So, and, or is basically add, but there's an adjustment. The only time I don't need this is if I know they're mutually exclusive. Do we know that? No. Right? I don't want you guys, I want you to understand, this is exactly the process. Write the formula that tells me what they're asking for. I got this, I don't got that shit. Did Jeff tell us that? No, the jerk. Damn it. So then I'll take a second. Do I have information that will give me this? Which formulation do I need to use? There's two, isn't there? Well, what is it we know? PB given A, right? So which one do I want to use? Second one. Can't I then figure out what P of A and B is? I know this is everybody's favorite kind of problem. The problem that's like, you got more steps, but that's real life. So probability of A and B equals probability of A times probability of B given A, correct? Let's see if Jeff made a good problem. I don't know. Somebody help me out. What's important right now is, do you guys understand the motivation behind everything I did? That's what's important. I am doing this problem the same way you should do this problem, right? You write down, you ask me this question, well, there's a formula for it. Do I have everything I need? No, damn it. All right, let me focus on the thing I don't know. Let me find out what that is. So help me out, what is that? It's about 0.13.
0.28.
What is it?
0.285.
285? How did I get so far off? What is it?
My math is wrong.
Yeah, this is 1,
I
2,
did the wrong one.
7, 3? Okay. For a moment, I was questioning my entire math ability. I was like,
I
damn,
did the wrong one.
I was really off. Now do I have everything I need to be able to answer the question? The question was PA or B, correct? We know PA, we know PB, and now we know PA and B, right? So now we can do it. So it'd be PA plus PB minus this. Oh, neato. 6101, I think. No, 7101. Somebody save me for myself. What do you guys get? So it's 0.2561 plus 0.5813 minus 0.1273, correct? PA plus PB minus PA and B. Is that cool? So what's that? Forgot what I said. I said
7101.
yeah, that's what I said. Yeah, okay. So again, this is the trap I think that a lot of our math education puts you guys in. You expect to get a problem that's exactly like another problem you see. No. There are ideas, and then you have to apply them. So, if I give you a probability problem like this, and I ask you a question, okay, write the formula for that. And then your next focus is going to be anything you don't know that you need for that formula. I can't do this formula until I get all of these three things. I didn't have that one. Now the problem becomes, what's that? You guys with me? You write the formula for what that is, and you just throw shit in. And then you're there. You're golden. Okay, maybe. You guys like that one a lot, I can tell. Okay. So,
What's it called? Like the formula?
what's oh, which one? Sorry.
Just in general, like what's it called? Like, does it have to match that in term?
Which one? There's many formulas up here. So these are all probability formulas, right? This is the OR formula, this is the AND formula, this is the given formula. What can you not put in your formula sheet? Well, here, look. I have to let you put that word, right? All right. So I don't want any smart asses not putting words. Okay, you can put those words, that's fine. So, I want to do an example like this to show you that there are situations where you have to use the formulas. Just remember, if I give you a chart, you don't have to use the formulas at all. You just apply the idea, right? And what's the idea of probability? The probability of something equals what? What's on the top? The number of things that? The number of things that match what I'm looking for, divided by the total number of things, right? Okay. All right, let's see how it goes.